Hello everyone. Welcome to my presentation. As you all can see the title, I have been assigned with the topic moment about a point 2D. So before getting into the question, we can see what is moment to get a clear understanding about the topic. So now we can see what is moment. A moment is a measure of force tendency to cause a body to rotate around a specific point or axis. In simple words, the turning effect of a force on a body is called as moment. That is, a torque is basically known as a moment. The formula which is used to calculate moment is R cross F, that is Rf sine theta, where F is the force vector and R is a vector from the point we are taking the moment about to any point along the line of action of the force. So here is the question. The 1800 Newton boom AB and the 250 Newton cage BCD, the 600 Newton man have centers of gravity located at the points G1, G2 and G3 respectively. Determine the resultant moment produced by all weights about point A. So here is the diagram provided for the question. Now let's move on into the solution. The solution for the given question is being provided here. So we are given with data such as W1, which is the weight of the boom, which is 1800 Newton. W2 is considered as the weight of the cage, which is 250 Newton. And W3 is considered of the weight of the man, which is 600 Newton. So let's now move on to solution. So basically you have G1 right here, G2 right here and G3 right here, which each one creates a downward force with their weight. So basically, to find moment, we always want to draw a lever arm or consider lever arm. So we can consider a lever arm here, which creates three different legs. We got with for three different forces. So from left to right, like from point A to G1, we consider the length between A to G1 to be as L1. From the length between A to G2 is considered to be as L2, and the length from A to G3 is considered to be as L3. So, and so as you can see, the first force is turning L1 and L1 is equal to 10 cos of 75 degree, because we are given the angle to be 75 degree, and then the hypotenuse of a right triangle is also given. So here from all the way up for G2, we can see that the length of the arm is considered to be as 10 plus 20, that is 30 meter, and then one more distance of 1.5 meter is being added. So L2 is 30 cos 75 plus 1.5. And for similarly for G3, we can see another 2 meter is being added. So for L3, the equation is to be 30 cos 75 plus 1.5 plus 2. Now we have found the equations for L1, L2 and L3. Now let's find moment. So we can consider or assume that the counterclockwise is positive. We can find that moment of G1 is minus W1 10 cos 75. So minus W1 is considered to be as 1800. So we get a value of 4658.74 Newton meter. The negative sign indicates that it is turning the little arm clockwise. So similarly for we assume a M2 is also moving in counterclockwise direction. So we take the equation to be minus W2 30 cos 75 plus 1.5. So here W2 is given as 250 Newton. As we substitute the values, we get minus 2316.14 Newton meter, which is similarly says that it is moving in a clockwise direction. And similarly, which goes without saying for M3, that is we take the direction to be, assume the direction to be counterclockwise, and we substitute the values and we get the point to be minus 6758.74 Newton meter, which also gives us the data that it is moving in a clockwise direction. So we have M1, M2 and M3. To find the resultant, we add the separate values to find the resultant value of this. So on adding, we get the value to be minus 13,733.62 Newton meter, which the negative sign indicates that the river is moving in a clockwise direction.